So last time we dove into this stuff, we used a classifier, but I kind of just handed you the keys, right? I gave you the theta, those crucial parameters. That's a bit like driving a car without having a clue how the engine works. Well, today, we're popping the hood. We're going to learn how to train our very own classifier, right from scratch. And that brings us to the big one, the question that's really at the heart of all of this. How does a machine actually learn? I promise you, it's not magic. It's actually a pretty methodical, step-by-step process. Our job today is to pull back the curtain and see exactly how it's done. So here's our mission, if you choose to accept it. We are going on a quest to find the perfect set of parameters. We call this theta. You can think of theta as all the little tuning knobs and dials on our model. If we can find just the right settings for those knobs, our model gets smart and starts making accurate predictions. Okay, so to find those perfect settings, we can't just start twisting knobs randomly. That would take forever. We need a guide, some kind of map. And in the world of machine learning, our map is something called the cost function. This is what's going to guide us on our journey to the perfect theta. All right, now take a look at this. This is our map. I want you to imagine it's like a topographical map of a huge valley. Every single point on this map, literally every pixel, represents one possible setting for our parameters, for theta. And the altitude, well, that represents our model's error, what we call its cost. So the higher up you are on this map, the worse our model is doing. So our goal is pretty simple, right? We need to get to the lowest possible point in this valley, that sweet spot right in the center, because that's where the cost, or the error, is at its absolute minimum. And when we get there, it means our classifier is performing as well as it possibly can. Our quest for theta is really just a quest to find the bottom of this valley. Okay, so we have our map, but how do we actually navigate it? I mean, we can't see the whole valley at once. We need a method, a reliable way to make sure that every step we take is a step downhill. And that method has a name, gradient descent. So what is gradient descent? Put simply, it's our algorithm for finding the way down. It's the super powerful technique that's used all over machine learning to hunt for the exact values of our parameters, our theta, that get us to that lowest point on our cost function map. You could think of it as our compass and our hiking boots all rolled into one. So how does it actually work? Well, this quote from the source material really nails the core idea. You see, the gradient is just a fancy term for the direction of the steepest slope from wherever you're standing. So gradient descent does something really simple. It looks around, finds the absolute steepest path downhill, and just takes a step. And then it does it again, and again, always moving in the direction that lowers the cost the fastest. So we have our map, that's the cost function, and we have our method for navigating it, that's gradient descent. Now let's actually put on our boots and start the journey. Let's see how a machine learns, step by step. And here it is. This is the blueprint for learning. This flowchart shows you the whole iterative process. Now, the most important thing to notice here is that big arrow looping back on itself. This is not a one-and-done kind of thing. It's a loop that our model runs through over and over and over, getting just a little bit smarter with every single pass. Let's break that loop down. It's pretty straightforward. First, we just guess. We initialize our parameters, our theta. That's like being dropped somewhere totally random on our map. Then, step 2, we use those random parameters to make a prediction. Step 3, we calculate the gradient. That tells us which way is downhill. Step 4, we take a tiny step in that direction by updating our parameters. And finally, we check our new cost and, you guessed it, we repeat the whole process until we hit the bottom. So, after walking through that loop again and again and again, what does it actually look like? What's the result of all those tiny little steps downhill? Let's watch our algorithm finally reach its destination. And here is the payoff. This is so cool. Look at these two plots together. On the left, you can see our little green dots, which represent every step we take, marching steadily towards the center of the map, that low point. And on the right, you can see exactly what that means for our performance. With every single step, with every iteration, the cost just plummets. Our model is literally learning before our eyes. So after doing this hundreds, maybe even thousands of times, we finally arrive. You can see the green dots are all clustered right there near the center of the map. And if you look at the graph on the right, you'll see the curve has totally flattened out. That's the signal. It means we found a theta that's incredibly close to the best possible cost. We really can't get much lower. And with that, mission accomplished. We started with a completely random guess, and just by repeatedly taking a small step in the right direction, we navigated our entire map, and we found the treasure, a perfectly trained set of parameters. We have found our theta. Our model is now officially trained. But hang on a minute. We found the bottom of the valley on our map. We minimized the cost for the data that we used to train it. But does that automatically mean our classifier is going to work well on new data it's never seen before? I mean, is it actually any good out there in the real world? And that leaves us with a really important realization. Training is only half the battle. Now we actually have to test it to evaluate our model's performance. So how do we do that? Well, that is a fantastic question for our next explainer. We'll see you then.